Screen for the classified topic 7. You can use screen annotation or say the answer. Use your mic. Aluminium oxide is amphoteric. Amphoteric, what is the characteristic of amphoteric oxides? Amphoteric oxides are not dissolving in water and it can react with both acid and alkali. So describe an experiment to show aluminum oxide is amphoteric. So what we do, we add it in a base and it will dissolve. If we add an acid, it will also dissolve. Or you can also, instead of dissolving, you can also say, use the term react. Okay. The distribution of the marks I will show because the marking scheme is there at the last of every question.
Only these 2 points.
So here, add name acid. Like you have to name, like example, you mention add hydrochloric acid. Aluminium oxide will react or neutralize with both reagent. So it will dissolve to form a solution. So the structure of the answer will be add an acid, like example, hydrochloric acid, aluminium oxide will react and it will dissolve to form a solution. The second thing, add an alkali, but it should be a named acid. Like you cannot say name alkali. You cannot say add alkali only. It's specifically like add sodium hydroxide or potassium hydroxide and it will also dissolve. The next is silicon 4 oxide has a giant structure. So if it has a giant, name the type of a bonding in silicon 4 oxide. What kind of bonding silicon 4 oxide is having? It is no type of bonding. Type of bonding can you have learned. Actually, 4 types of bonding are there: ionic, covalent, metallic, and dative. But you are not learning anything about dative. So only 3 type of bonding you have learned: ionic, covalent, metallic. So type of a bonding cannot be macromolecule. Type of bonding can be either ionic, covalent, or metallic. So silicon and oxygen, because 2 non-metals are there, so between the non-metal, it is always a covalent bond. No, type of bonding cannot be giant. The structure can be giant. Structure can be simple covalent structure or a giant covalent structure. Type of structure. But the type of a bonding is either ionic, covalent, or metallic. Because it's a bond between silicon and oxygen, that's why it should be. State 2, physical properties. Physical properties like you can compare density, electrical conductivity, the states, the melting point, the boiling point. But if you mention a melting point, don't mention a boiling point because they're counted as one property. It's obvious if the melting point is high, the boiling point will also be high. So physical properties, it does not conduct electricity, it is hard, or you can say it has a high melting point.
Ionic bonding, bonding between.
Ionic bonding, the ionic bonding, it's actually a bond between the bond which is formed by a transfer of electron and the electrostatic attraction between the oppositely charged ions. So the standard definition is 1 mark you will score for electrostatic attraction and 1 mark you will score between the oppositely charged ions. So if you say a bond between a metal and a non-metal, I will show you the answer key and you try to find out where they write metal or non-metal. They don't write that. Why they don't write? Because this is not the standard definition. Standard definition of ionic bond is a bond which is formed by it's an attraction between the oppositely charged ions. So 1 mark is for mentioning oppositely charged ion and 1 mark is for mentioning electrostatic. So if you say a bond between a metal or a non-metal, you will not score the mark. But because it's obvious it is formed between metal and non-metal, but you have to explain what is ionic bond. So ionic bond is the attraction between the opposite charges or positive and negative charges. No, a standard definition, as I mentioned in exam for, let's say you wrote the ionic bond is a bond which is formed between a metal and a non-metal. Exam point of view, you will not score the mark there because that is not the standard definition. The standard is electrostatic attraction between the oppositely charged ions. Not sharing of electron. If it is a sharing of electron, then what it will become? It will become covalent. So this is also not the right.
So what will be the example?
So exact definition, it is a electrostatic attraction between the oppositely charged ions. Lattice is how they are arranged. Lattice is a part of the structure. Like when lot of ions are there, positive and negative, joined together in a regular manner, that is called a lattice.
So, sir, if they ask us what
If they ask explain the ionic structure, then you will say it consists of oppositely charged ions which are arranged in a giant lattice. Next is deduce a formula for calcium phosphate. How we deduce the formula? Calcium belongs to group 2. So it will be 2 plus and a phosphate valency is given 3 minus. So when the valencies are not same, we just cross multiply. So this 3 is with calcium and 2 with phosphate. So it will be Ca2, PO4 in a bracket. Sorry, this will be 3 and this will be 2 because the cross multiplication.
So if they ask us what is the definition for covalent bonding?
Covalent bond, it's the attraction between the electron and the nucleus by sharing of electrons between the two atoms.
The weak attraction.
No, covalent bond is strong. It's a misconcept that students think covalent bond is weak. Covalent bond is not weak. Like example, if one chlorine is bonded with another chlorine, this is strong. But intermolecular force is weaker. Like between the two chlorine molecules, a weak force. But this is a strong. Covalent bond is not a weak bond, it is a strong type of a bond. But between the molecule, it's weak. With ionic compound, what happened? They have a lattice. So in a lattice, oppositely charged in a regular manner. So it's hard to separate all of them together. So that's why we say they have usually like ionic compounds, they have high melting point because of strong force between the oppositely charged ions. This is related to moles. We'll do this, inshallah, this coming week. We'll start the moles. Today we'll focus on completing this topic 10.
So wasn't it complete? 10?
10.
9?
Topic 10. 9 was metals.
Finished? That is easy.
We did aluminium, that's it. And copper.
Copper?
Copper was there in electrolysis using anode and cathode. Silver dichromate is a red insoluble salt. Silver dichromate can be made by reacting a silver nitrate solution with ammonium dichromate. The chemical equation for this reaction is shown. Describe how would you obtain a pure dry solid silver dichromate after mixing silver nitrate and ammonium dichromate. So this is, as you can see, this is a solution. Aqueous means this is also a solution. This is a solution and here is a solid. How we can obtain a solid, how we can obtain this solid from the mixture? So what we should do? First thing, no, it's already mixed.
Yes, sir.
Describe how we obtain pure dry solid after mixing. So it's already mixed. So what we'll do? We'll filter to remove silver dichromate.
Then we wash it with water.
Then we'll wash with the distilled water.
Then we will dry it by a tissue.
And then we will dry with the tissue paper.
Yeah.
Or you can also say filter paper.
Filter paper?
Yeah. The charge on the silver here, the charge on the silver is +1. What is the charge on the dichromate ion? What could be the formula is written Ag2Cr2O7. The question is, what is the charge on this ion?
PR.
What is the charge on this ion? Silver is 1 dimension here.
Yeah.
So what should be the charge here? On this ion. How we work out? Look, I will give another example so you'll just relate. If I have magnesium chloride, MgCl2, what is the charge on magnesium? So this number 2 is actually for magnesium. And this number, what is written, nothing is there. It means 1. So this 1 is for chlorine. So same thing. If it is AgCr2O7, Ag2Cr2O7, they are saying, what is the charge on AgCr2O7? So this 2 which is written with silver is actually the charge of the chromate. And this 1 which is written here, like nothing is there, it means 1. That is the charge of the sodium. That's because when we write silver, sorry, when we write the when we write the formula, we cross multiply the valency. And what about the nature? Because it is a second part, it's a second part, so this will be 2 minus, and this is plus 1. So what is the charge on the dichromate? The dichromate charge is minus 2 or 2 minus. Not minus 1, it's minus 2. Like if I say I have calcium hydroxide, what is the charge of calcium? So this 2 is written here, yes? Because it's the second part of the molecule. If it's a first part of molecule, positive charge. Like if I say what is the charge of calcium? Plus 2. If, what is the charge of hydroxide? Minus 1. If I say I have
Why isn't the O1?
Na2SO4. So what is the charge of sulfate? What is the charge of sulfate?
-2.
So this 2 is with sodium, so the charge on sulfate will be minus 2. And nothing is written, so what is the charge of sodium? It will be plus 1.
That's right.
So they already mentioned this is a chromate ion and this is a silver ion. So silver was having 1, that's why 1 was here. So the chromate should have 2, so that's minus 2. Write an ionic equation for a formation of a silver dichromate. So a silver dichromate is formed.
Plus Cr2O7.
A silver dichromate Ag2Cr2O7. What are the ions present? We need ionic equation. So what are the ions present? It contains a silver ion, so plus, and it contains a dichromate ion Cr2O7 with a charge 2 minus. Is it clear? This one?
Yes, sir.
So if we want to write an ionic equation for formation of any solid, so if I want to write, let's say I want to write an ionic equation for silver iodide. So what is the ion present? It contains silver ion and it contains iodide ion. That's an ionic equation.
Yeah.
Same thing, if I want an ionic equation for silver dichromate, which is Ag2Cr2O7. So what are the ions present? It contains a silver ion and it contains a dichromate ion. This is the dichromate ion. And this is silver ion. Like they combine with each other to form silver dichromate. Next is dilute sodium hydroxide was added to ammonium nitrate. Whenever we have a alkali and we are adding an ammonium to ammonium salt, what will be the product? So the mixture is then warm and a universal indicator paper was held above the reaction mixture. State and explain what will happen to universal indicator paper. Look, if you have an ammonium salt,
will turn blue.
so you have ammonium salt, you have ammonium nitrate, yes, and you add a sodium hydroxide. So whenever alkali and the ammonium salt, and we supply the heat energy. So when we supply the heat energy, what will happen to the universal indicator paper? The universal indicator paper will turn blue. Why? Because it releases ammonia. What will the product when sodium hydroxide react with ammonium nitrate? So it will produce sodium nitrate, ammonia and water. So state and explain what will happen to universal indicator paper. It will turn
Blue.
And why it will turn blue?
Because ammonia is a alkali.
Because ammonia is released which is alkaline. So the nature of ammonia, it's alkaline. That's why it will turn the universal indicator paper blue.